Welcome to this demonstration of the EDS-10G Ethernet Delay Simulator, manufactured by East Coast Datacom, located in Rockledge, Florida, USA. This short demonstration will provide users with a basic understanding of the hardware and software that encompass the EDS-10G system. First, let's look at the hardware for the main system and the optional LAN interface cards used for IP latency and impairment testing. Each system is comprised of a single standalone or front mount chassis. The chassis has 7 PCIe slots located in the front for easy access. When you order the EDS system, East Coast Datacom will pre-install the LAN cards based on your purchase order. The available cards are 10, 100, 1000 copper, 1G fiber with SFP inserts, 10G with SFP plus inserts for fiber or twinax, or 40G QSFP plus inserts. The EDS system may be loaded with up to 16 ports of 10, 100, 1000 copper interfaces, 8 ports of 10G, and 2 ports of 40G. Most users will order a variety of interfaces such as 10, 100, 1000 copper, 1G fiber, and 10G fiber. The only limitation to the number of interfaces is the available PCI slots and the number of Intel Xeon cores in a chosen system. The number of cores may be upgraded as well based upon the user's requirement. The EDS-10G hardware and software have a 3-year warranty with factory support. As well, this warranty includes 3 years of system software upgrades to the user. The user has a full usage single license for each system that does not restrict bandwidth usage or features in any way. Now let's move to the EDS-10G GUI for review. First, we log into the system with a unique login and password. Now, at the top of the screen, the user is presented with a view of the available management ports and LAN ports used for network latency emulation. The LAN ports are presented by color: red, green, or yellow when an emulation is running, which we'll see in a bit. Next, the user is presented with several tabs to choose from: the dashboard, which shows the available bandwidth; the emulation tab, which allows the creation, editing, and deletion of an emulation; the statistics tab; the system settings tab; the help screen; and the admin screen. Now, for this demonstration, we're going to create a 10G emulation profile with 20 and 35 milliseconds of delay and add 10% loss on one of the LAN ports. First, we have to give the profile a name. Then we choose the bridge mode. We select the LAN interfaces, ETH2 and ETH3. And then we have the default rules. So basically we're going to select delay. In this test we're going to do a constant delay. We'll do 20 milliseconds on this port and 35 milliseconds on the second port. And we're going to show 10% loss on this port. The user also has the option for advanced rules, packet reordering, packet duplication, and packet corruption. As well, if you're using route mode, there are other options available, such as filtering. Now we simply save the profile. And now we start the profile. And now let's switch over to the EDS traffic generator, which for this test we're going to use the XVO traffic generator. I have pre-set up some streams of traffic with varying frame sizes, and actually this is a mixture of data, voice, and video. So now we're going to start the tester. And this channel has 35 milliseconds of delay for all of the traffic. See, no frame loss, no out of sequence. Second LAN channel, we're going to see frame loss because we do have 10% set for one of the channels, and also the latency is 20 milliseconds as we had set up in the EDS profile. Now if we move over to the EDS system, the user can go to statistics and see the traffic running. You see that there's packet drops, which we have a 10% loss set up. The delay is 20 and 35. The user can also click on this graph where you're presented with packet throughput showing millions of packets per second. We have a packet counter and loss. The loss is shown right here, which we have set at 10%. And then if we go to the second channel, we should see no loss, just packet throughput. Again, this is just packets per second. If we move to the dashboard, we can see the actual packet throughput. We have 9.1 gigabytes. We have 8.2 because we have 10% loss on this channel. If we click on the stats, again, this tab here shows the actual throughput. This shows both of your Ethernet ports, 2 and 3, that we have in the emulation, one being faster than the other because of the loss. If we go to the other side, we should see, okay, here, perfect. Back to our stats. So if we want to cross-check back over to the XVO, the XVO has the ability to look at the streams, at the traffic, and that's for each port. As you can see, this side has no loss. So this gives you a general idea of the traffic being passed through the XVO traffic generator. We'll go back to the EDS system. Some of the other options that a user has through the system settings. There's a console screen where you can enter in your commands. We have a system update screen. You can load the factory defaults. This tells you about this system. This is a 12-core system. can power down the system. We also have the ability to do system upgrades right through the web user interface. There's a user management tab where you can set the roles and permissions for each user. You can have multiple users logged in, one at a time though. There's a management configuration screen where you set up the management ports. Management 1 ships from the factory with a predefined address. You can change the address, but upon power reset, the box will always go back to the factory default so that you always have a known starting point. Management 2 can be set to any address for the user's network for access. We also have a help screen. The screen will show you the number of cores running, information about the box. And then we have an admin screen where you can change the password or log out of the EDS system. The EDS-10G is a cost-effective test solution based on COTS hardware and coupled with leading-edge proprietary software with an embedded user space application, user space drivers, all based around Intel Xeon processors and the latest Intel server NIC cards. The system is available with a single or dual redundant power supplies. The typical EDS system costs less than $12,000, which includes the 3-year warranty, support, and system software upgrades. I hope you have enjoyed this short demonstration of the EDS Ethernet delay emulator.